Hello everyone, it's Ms. Emily and thank you for joining me with another STEM video program. Today we will be using food to learn about the scientific concept of magnetism. Now this happens when electrical force is created by moving electrons in the same direction. We can explore magnetism with magnets. Have you ever used a magnet before? These are some refrigerator magnets here. And magnets have both a north and south pole. And the opposite poles will attract each other and the same poles will repel. So with this refrigerator magnet here, I'm going to come close to the screen and you're going to see how they're repelling and attracting. So here are my two magnets. If I put them together on the top part, they stick. But if I go down below, they're actually repelling. I can't actually make them go together. But as soon as I go and have it near the opposite poles, they will attract. But I put the similar poles together and as you can see, they keep on bouncing away from each other. As soon as I have those opposite poles, they stick. Now the way a magnet actually works is they are attracted to things that have either iron or cobalt or nickel in them. It's a specific type of metal. And I have a whole bunch of items on this table here, and I have a little bit stronger magnet than the refrigerator magnets. And I want to show you some things that do and do not attract to the magnet. So here I have a bag of pretzels. Do you think that this has iron, cobalt, or nickel in it? Nope, nothing is attracting. Here I have a can, an aluminum can. Now it's an aluminum can. Does it have iron? Does it have cobalt? Does it have nickel in it? Let's see. Nope, does not attract. Now here, this is a shiny wrapper from a fruit and nut bar. This has probably got iron, cobalt, and nickel in it. When I look at the ingredient list, it says there's iron. Let's see. Nope, must be in the food item instead. Here's a tin can. Our aluminum can didn't work. I wonder if this has iron, cobalt, or nickel in it. I think it does. This is what helps recycling occur for different types of metals. They have magnets, and things that are magnetic are sorted out from things that are not. Here I have a glass bottle from root beer. I wonder if this has any metal in it. Nope, not working there. And a plastic bottle. Now our plastic bag didn't have any in there, so what do you think is going to happen with this plastic bottle? Nope, it's not magnetic either, not attracted to that magnet. Well, now that we played with a whole bunch of magnets, you're probably going, Miss Emily, you said this was going to be a STEM program that's going to use food. Where is the food? Well, we are going to check out iron in cereal. If you've ever had cereal before, you might have noticed they have nutritional labels on the side. Have you ever looked closely at those nutrition labels? It tells you what is inside the food. This box of cereal says it has 70% of your daily iron in one serving, and that's 12.6 milligrams. This box of cereal says it has 30% of your daily iron in one serving, and that is 5.4 milligrams. And in this box of cereal, it says it has only 15% of its daily allowance of iron, which is only 3.1 milligrams of iron. I know that we all need iron in our red blood cells to help carry the oxygen throughout our entire body. And fortified iron is a food-grade iron that is inside a lot of food. It is not the same thing as iron in this can that was magnetic and we're eating the can, or a nail or something else that has iron in it. So I'm curious, if each serving of cereal has a different amount of fortified iron in it, will we actually find different amounts of iron in the cereal? This sounds like a science experiment. Well, we're going to have to use the scientific method in order for us to figure this out. Let's go take a look. All right, so here is the scientific method. The first thing is the question. You want to ask yourself, what do you want to learn more about? And what is actually happening? My question is, I wonder why, if all these different cereals have different levels of iron in them, will I find different levels of iron in each serving? That's my question. Then hypothesize. So that's when you have to research and take an educated guess. So doing some research, I found out, just like with the fortified iron, that yes, they should technically have more iron, fortified iron fillings that you can actually find in the cereal if it has more iron in it. So I did some research, I looked up some books, I went online, looked at some databases, lots of different things, and looked at even at videos, and they have found that high iron cereals, you can find the iron easier in them. So if it's easier, there should be more. That's my thought. So now we have to create an experiment. So we want to test our hypothesis. So my hypothesis is, I believe we will find more fortified iron in the cereal that has the most fortified iron daily allowance. So my experiment is going to be using this strong magnet, and we are going to be taking half a serving of each of these cereals, putting them into identical containers. We're going to be adding identical amount of water, and we are going to be breaking up the cereal and then taking this magnet along the edge of the cereal that's all broken up to see if we can pull out any of the iron. And we're going to see if we can find the most iron in the cereal that has the most daily allowance of iron in it. The only thing that's changing is our cereal. Everything else is the same. That's very important when you're doing an experiment. You only want to change one variable. So we have the same magnet, the same type of container, the same amount of water. We're doing a half a serving of each one, just so that my containers aren't that big. So I wanted to make the amount smaller in the cereal. So if I halved all of them, all the numbers will be in half as well. And then we have to observe and record what actually happened, as well as analyzing and seeing if my hypothesis was correct or not. So let's try my experiment. The first thing I have is 3 identical containers with lids. I have some water, my cereals, measuring cup, as well as my magnet. So the first thing I want to do is I want to get half a serving of each of my cereals into each of the plastic containers. I'm going to do the smallest one first. Their serving is 1 cup, so I'm going to use half a cup, and because this is a 1/4 cup measurement here, I'm going to use 2 of these. So there's 1/4 cup. And I have to do another 1/4 cup. All right, so that is half a serving of this particular cereal. Now I need a half a serving of this next cereal. Now it says here a serving is 1.5 cups, so I need 3/4 of a cup to make half a serving. So I need to do 3 of those measurements in this particular cereal. 1, 2, 3, and for my next cereal, it is also 1.5 cups per serving. So in order to get a half a serving into my container, that will mean that I need to do 3/4 cup. cups. One, two, three. Now some of you might be going, Miss Emily, you have more of these other cereals than this one. Yes, but to make the math easier, I wanted to go half a serving, whatever that serving was, versus trying to get the same amount of cereal, because then it would actually be a different percentage of iron, and I would have to figure that all out, and it's just easier to say half. All right, so I have my 3 containers here of cereal. Now they all have a white line on these containers, so I'm going to add the same amount of water to each one, up to that white line. Put the lids on. And I gotta shake, shake, shake until the cereal breaks down. Sure those lids are on tight. Shake, shake, shake till that cereal becomes all nice and mushy. Breaks down. Shake, shake, shake until the cereal becomes all mushy. These are stackable containers, so I can shake them all together. Whew! This looks like it might take a while. Okay, well, I'm going to keep shaking these, and when they're all broken down, we'll test them with the magnet. We'll see how long this takes. Okay, so I've been shaking for about a half hour now. Whew, that's a lot of shaking. If you're going to try this at home, number 1, ask an adult to see if you can destroy some cereal, because you're not going to want to eat it after this. And number 2, whew, you might want to let the cereal sit in the liquid, the water, overnight to really soften it up, to make it a lot easier to break up instead of shaking and shaking and shaking. So this right here is my Fruity O's. This right here is my Honey Nut O's. And this right here is my Crispy Rice cereals. So now I'm going to want to see if I can use my magnet, see what I can pull out. So the least amount should be the Fruit O's. So let's take a look at the Fruit O's. Have my magnet. This is really gross, everybody. I'm just letting you know. Magnet, magnet, magnet. Ugh. And I'm looking. And I'm seeing a few little teeny tiny black things that are stuck to the magnet area, but not that much. So let's see if we do the one that has a slightly more iron, and if we can find slightly more of the little black iron, fortified iron in it. Okay. So I'm going to put this around my magnet. Try to get as much of the liquid touching the magnet as possible. Now this is a pretty strong magnet. Let's see here if I raise it up. Again, I see a few little pieces, but not really that much. I'm hoping high iron that has 70% of our daily allowance, if this will improve. Let's see here. So again, I'm doing the exact same thing. Spinning the container. Drawing it up. I'm not seeing many more filings on any three of these cereals. So even though we have 70% and we have, let's see here, iron, 15%, I'm having a hard time finding different amounts of iron in each one. For this particular experiment, I'm going to say my hypothesis was incorrect. I was unable to find more iron in the higher iron food, and that's okay. So if we go back to the scientific method that I have up there, we analyze our information, and that's pretty much what we have. Now this was a very small sample. Good scientists will repeat this experiment many times over. Maybe I'll add a lot more water so that there will be separation similar to the O's here. The fruit O's, there's a separation of the water and the material. Maybe that will help. Try that. I can also try a stronger magnet. These are pretty thick containers. I might try a thin container like a plastic baggie for these solutions, but I only want to change one thing each time I try it out. Now remember, if you do want to try this at home, again, get your adult's permission because you will be using cereal and won't be able to reuse it again after you have it here. Well, thank you for watching this STEM video. If you recreate this experiment, make sure you send me your results to youthservices@olpl.org. Also, if you want to try a different experiment, we have lots of great books here at the library. We have Edible Science, Magnetism, Chemistry You Can Chomp, and Magnets Push and Pull. Also, if you want to see any other STEM videos, you can check out our YouTube page at the link up ahead. Thanks so much again!